right, now that we have looked at the impressive athletic prowess, let's have a look at the physics behind, the action. So we're gonna use basic physics that describe pull-ups and muscle-ups. And actually, the starting point would be to look at the energy and the power. The two are very related to each other. And I think you would understand with simple math. So let's use myself as an example. I weigh 70 kilos, so my mass is 70 kilograms. And from the center of mass, you can see a force that acts upon, the gravitational force that acts upon me. It will be a vector pointing toward the Earth's center. So we can write F equals mg. And my mass is 70 kilos. Let's just skip the unit. G would be 9.8 if you use a standard average value for the Earth. And that would be roughly 690 newtons. I just write N, standard. And there are two more forces that counteract these gravitational forces. Gravitational force that acts upon me toward the Earth from the center of mass. So the two forces would be the normal forces on this palm and that palm, 345 each. 345 newtons on the left and the right, unless you modify your hands, which I don't think you can do. And then when it comes to the pull-up action, all you have to do is pull up, but it's actually an accelerated motion. You will have to approximate, and I do it strictly. So basically, I do it very slowly, and I can do 23. That's my record. So when I measure, you can ask your friend at the local gym, and that will be 65 centimeter. Measure, doesn't matter the top of your head or your feet. And if you do that constantly, then you have quite a good value for the distance you travel or you actually move upwards. In this case, I have 65 centimeter, and the energy required would be the potential energy that that exists because I'm in the gravitational field of the Earth. So mgh would be just this number, 690 newtons multiplied by h, and 65 centimeter is 0.65 meter because we are computing in SI unit, and that would be 450 joules roughly, J. So basically for each rep, this is the energy that I burn that is required. So I need to have quite a lot of energy if I'm going to do a lot of pull-ups, right? But that's not enough. We want to know the power output from each pull-up. And you are very interested in the power output, especially when you think about cars or you want to buy a new car. And the energy, the power output is pretty easy because you're going to use the formula P equals W divided by T. W over T would be this number, 450 joules, divided by the amount of time that this action takes place. It happens to be 0.5 seconds. I actually check it on my clock roughly, and I asked my friends when I met them at the local gym, and they say, yeah, that sounds reasonable. So 0.5 second, and joule per second is called watt. So this would be 900 watts. But we write like this, roughly 900 W watts. And not only that you can express the power output in watts, you want to do it in horsepower. That's kind of cool, right? And in the SI unit, you divide it by 746, and that will give you the horsepower output of about 1.2 horsepower for each pull-up for myself. Now, we want to even look at the muscle-up, which is way more difficult. Not many people can do muscle-ups, said my PT, personal trainer. Pull-ups is way easier because you don't have to do a lot of timing in each rep. But for this exercise to be successful, you have to pull up explosively so that you will be over the bar, and then you have to use your tricep and other muscle to push you forward or upwards. And in my case, I have 5 as a record, 2 or 3 I usually can do on any day, but 5 it had to be a very good day, and I have to be kind of warm in my muscles. Otherwise, I may get injured. So this one corresponds to 1.3 because the distance here is basically double that distance. So 1.3 meter, meaning that the energy required would be 900 joule for each muscle up, and the horsepower output would be around 2.4 horsepower. So basically, this is the horsepower that I generate. And I don't know if I actually can generate a lot more than that, because I can do a deadlift as well. And I maybe have 150, 160 kilograms deadlift. But the thing is that the distance travel is not that great. And the time, maybe the time. I would have to check that. So let's get back to that another day. I will have to go back to the gym and do the deadlift and see what I can do at best, all right? So hope you enjoy this, and if you want to succeed in pull-ups and muscle-up, you will have to both train your strength and some technique. Even the pull-ups, the grips, the width of your grip is very important, because you have, maybe your best strength when it's not so wide or not so narrow. Just check out, and practice makes perfect. Until next time.